Hello guys and welcome back to CS with Mr. G. This is the start of a new unit, Unit 4, and as you can see we are currently here in the syllabus covering the topics 1, 2 and 3 so far. This is a relatively short unit which should only contain about 3 or 4 lessons and is all about the topic of software. This lesson in particular, we are going to cover these topics here, and as you can see we are going to first compare the difference between what we call system software and application software. And we need to understand what kind of software falls into these categories, giving examples and explaining why they fall into each category. We also need to describe the role and functions of the OS, of an operating system, again looking at examples and real-world uses of operating systems, which no doubt you will have seen in your lifetime. We will also look back at Unit 3 and look at how hardware plays a vital role when it comes to the operating system and application software, and how it all works together as one system in order for us as users to perform our everyday tasks. And finally, we're going to look at this term interrupts, describing the role of an interrupt and what happens if our computers are ever interrupted. So although it seems like quite a lot, most of these topics are quite simple to understand, and as always I'll try my best to explain using real-world examples and breaking it down to a level that is easy to understand. So first and foremost, we need to understand the types of software that exist. But before we do that, let's just look at the word software and understand that software is any program on a computer, typically anything other than hardware. Hardware, which we've discussed in Unit 3, are all the physical components of a computer. Software is the stuff that is run on the computer, and a big clue in the name application, so all the apps that we use, systems that we use, the things that you tend to look at on your screens, these are all software. And back to these 2 points, system and application software, these are the 2 categories that we need to differentiate and label different types of software in these 2 categories. As you can see under the label system software, we have 2 further labels. One is operating systems and the other is utility software, which means that all types of operating systems and all types of utility software fall under the category of system software. We don't need to break the term application software up anymore. Application software is just apps, and we'll go into more detail later on in the lesson. So like I've mentioned, hardware is all of the physical components in a computer system, whether it's in the form of a desktop computer, a laptop, a smartphone, whatever the device is, it will be absolutely useless if it didn't have any software installed on it. So as you can see in the middle of this diagram, we've got hardware, and there's obviously many more components than just a CPU, a printer, or a hard disk drive. But as you can see, it's the middle layer. So all hardware belongs in the middle, with the next layer being what we call system software. And there we have the operating system and the utility software, like we previously said here. So the reason being why system software is layered around the hardware is that this is the first and probably most important type of software when it comes to a system. The system software is directly installed onto the hardware, which means that application software on the outer ring wouldn't be able to work without the system software beneath it. So in the application software ring on the outside, you can see we've got spreadsheets, any games that you might play, internet browsers, databases. The list could go on for any type of application software. But the point is that it's on the outer layer, meaning that it doesn't directly talk to the hardware. It goes through the system software first and then onto the hardware. So this middle layer of system software is the layer that allows us as humans to use our apps on different devices, on different types of hardware, with this middle layer being the middleman between the 2. So like I've mentioned, system software is the software that manages and controls the hardware, so it directly communicates with the hardware so that applications can be used, can be installed, but the system software acts as a bridge between the 2. So it's the bridge between our user applications and, like I've mentioned, the hardware as in the device itself. So let's just take Apple as an example. If you have an iPhone, an iPad and a MacBook, all of those physical devices are made up of glass and metal and plastic and all these different materials, yet each one has a different operating system installed on it. On the iPhone, you've got iOS, on the iPad, you've got iPadOS, and on the MacBook, you've got macOS. Then on top of the operating systems, you have all of your applications, which you use day to day, whether it's Safari, the Photos app, the camera, all the apps that you use as a general user, they would not exist or be able to be installed if you didn't have that operating system layer underneath. So this definition is very important, guys, as you do need to be able to explain why system software is important and again acts as what we call a bridge between the user applications and the hardware. So if we break system software up into these 2 categories here, we've got the operating system, which we have many examples for, Windows, Android, iOS being 3 of the biggest examples. There are many more, but the operating system is the most important software on the computer. It manages the hardware, it directly communicates with the hardware, and again acts as that bridge between the application software and the hardware that we keep mentioning. We also have this term utility or utility programs. And utility programs are programs that perform a specific task which aim to maintain or optimize the computer. So they're not generally applications that we use to perform day-to-day tasks, but they are types of software that aim to keep the computer running like it did the day it came out of the box. So many examples here include antivirus software, disk cleanup tools, and backup software for backing up your files or documents. So although these do appear as apps on any touchscreen devices, we do class them as utility programs because their main intention is to keep your phone or laptop or computer running like it did from day one, to keep it clean, keep it safe, just keep it performing to the best of its ability. As over time you will install more apps, you will take up more memory, and hardware will also get old. So these programs aim to keep the life of a device as long as possible. Then when it comes to application software, if we just take the word app out of application software is any software that we use as a human in order to perform a specific task. So whether we're just writing a Word document, we're going on the internet, on social media, we're editing photos, all of these apps or these programs are what we call application software. So this is much easier to understand. We just have to shorten the word application into app and that they perform specific tasks when it comes to daily use of any device. So as long as you can understand the difference, and this diagram here, you should be fine when it comes to explaining the types of software that exist in a computer system. Now, if we look at our second learning objective, this one here, describe the role and basic functions of an operating system. This is quite tedious, and we do have to go into quite a bit of detail because as you can see, there are many jobs that are performed by the operating system. And ideally, we need to explain all of these points that you can see in this diagram. These 9 categories we can see here, we need to be able to explain each one of these so that we can show our knowledge of operating systems. So the first point, HCI, or what we can call a user interface. All operating systems have to provide a user interface for the user to use as a human being. How do we interact with the hardware? Well, an operating system will provide a user interface. And typically, most computers would include a GUI or a graphical user interface, which is any type of user interface that uses graphics like you can see here. Things like icons, images, toolbars, these are all using what we call graphics, and it's what we interact with in order to control the computer. So 99.9% of devices that we use nowadays will have a graphical user interface. An older type, which you might have seen probably in films, is what we call a command line interface, or a CLI for short, and that's what you can see here, where there weren't any graphics whatsoever. It was command lines and lines of instructions that you would write manually with no mouse pointer, with no images, with no graphics. Quite difficult to use, but this is how we started off many years ago. So a command line we do need to show knowledge of, as it is a type of user interface that still exists, but we just have to show awareness of it. And finally, we've got a menu driven, which you can see here. And if you've ever been to an ATM or a cash machine, the screen that you order your food on in McDonald's or any other fast food restaurants, or even the self-service checkouts in a supermarket, these will have a screen that you interact with where you are limited to the menus installed by this operating system. So although it does use graphics, we wouldn't class it as a graphical user interface because you are locked in to a set menu. If you're in McDonald's, you only have their options to choose from, whether you want to eat in or take away, the food that you want to order, and then the payment instructions at the end. The same for a supermarket. At the self-checkout till, you only have certain options to choose from on that screen. You can't just go installing apps and going on the web browsers. You are limited to a set menu. So this is what we call a menu-driven interface, and those are the 3 interfaces that we need to be aware of. Next, we have multitasking. This is really easy to understand, the running of multiple programs at the same time. So doing things at the same time on a computer is what we call multitasking. So on a Windows device or a MacBook, rather easy to do as you can have Windows open. Although it doesn't seem as easy on an iPhone or a tablet, multitasking still takes place. For example, if you're listening to music on your phone whilst browsing the internet, you are in essence multitasking and there are several apps running at the same time. And don't forget, the operating system is constantly doing things in the background without you even knowing. So as soon as your computer comes on, there are instructions being executed by the operating system that we don't even realize. And again, it's the operating system's job in order to allow the computer to multitask and do more than one thing at the same time. The operating system also serves as the platform in order to run application software. So I've already touched on this earlier on in the lesson, and as you can see, this green layer in the middle is the fundamental layer between the hardware and the application software. So the operating system has to allow for applications to be installed and for them to be run so that we can use them as users as smoothly as possible and no issues. So the running of application software, this applies to all devices, a phone installing apps, a computer installing software, or even a video game console. These also have operating systems, and simply playing your game would be classed as application software, but without the console's operating system, you wouldn't be able to play the games. So again, this middle layer is very important, and we need to be able to describe that. The management of user accounts is also easy to understand. You will no doubt have logged into a computer at some point in your life using a username and password, or even using biometrics nowadays, things like Face ID or fingerprint scanners. The operating system allows a device to have different users, have different settings, install different programs, and even manage your own documents. So again, a job of the operating system is the management of different user accounts. Managing of files, also easy to understand. File management system, naming files, opening files, copying and pasting files, managing different folders, managing who can access the files, all these points here, also a job of the operating system. And as you're probably aware, each operating system has its own way of doing this. Some people love to use the Windows file management system, other people prefer the Mac OS management system, and even now the iPad OS has been improved with a better file system. But again, a job that the operating system is in charge of. Now this term drivers is something that you don't tend to hear that often, but when it comes to hardware management, the operating system has to make sure that any hardware connected to a computer is able to operate. Now what this means is that all these devices here need to be able to be plugged in or connected to a computer and be able to run. Now although typically we just tend to plug things in and they work automatically, but in the background what's actually happening is the operating system is installing what we call drivers in order for these devices to work. So unless you've built a PC yourself and installed the hardware using drivers, you probably won't ever come across this term in your life. Because like I said, when you plug in things like a microphone or speakers or any of these devices listed here, they tend to just work automatically. You plug in a mouse and you can then control the pointer on your screen. But like I said, the operating system in the background installs the driver in order for the hardware to be able to talk to the rest of the system. So like I said, if you've installed a graphics card yourself into a desktop computer, you will 100% definitely have installed the driver in order for it to work. But typically, everyday users plugging in the devices on the screen would not need to do this. But you as a computer science student needs to know that this is a job of the operating system. Next is memory management, which is quite a technical term, and we have to trace our minds back to Unit 3 and think about the job of primary memory or RAM. Remember, RAM stores all of the currently running programs, and although it seems like an easy job to do, when you break this down into all of the programs that are open on the computer, there'll be millions of processes in the background that again the operating system is in charge of. The second you switch your computer on and it's loaded up, there is constantly data being exchanged from the hard drive and the RAM in the computer. And again, the OS will be in charge of this, making sure that it's copied over successfully without any errors, and that programs can open as they should, and we don't have any errors when we are opening our programs. So in order to do that, the operating system will track all of the memory locations in RAM, making sure it knows what's in these memory locations, if they need to be there. If a program is closed, can it come out of RAM and free up that space for something else? But like I said, there is lots going on. But what we need to realize is that it's a job of the operating system to manage memory or manage RAM to make sure that our computers run smoothly and we don't lose data or have any system crashes. Another technical term we need to know is the interrupt handling routine. And if we go back to the learning objectives, this was an objective in itself, as we need to be able to describe the role and operation of interrupts. And as you can see, an interrupt is a signal that is sent from a device or from software to the CPU, and it will cause the CPU to stop what it's doing so that it can deal with this interrupt. It will be the same thing as me teaching this lesson now, someone knocking on my door, me stopping my lesson, answering the door, and then coming back to my lesson once I've dealt with whoever was at my door. So the knock on the door is what we'd call the interrupt, but in terms of a computer, an interrupt can be sent from a piece of hardware or even a software. And as you can see in examples below, we've got things like an input or output process, so plugging in a USB drive, plugging in speakers. If we plug in an input or output device and the computer needs to do something, the CPU will receive this signal, stop what it's doing, and make sure that it's dealt with there and then. Also things like hardware faults. If a piece of hardware connected to the computer has a problem, such as a printer running out of paper, or paper getting jammed in the printer, or just any kind of hardware problem that a device might have, a message will display on the screen as the CPU will have received the signal and is telling the user that there's a problem and then giving them the options to do something about it. We've also got certain user interactions that could cause an interrupt. Things like pressing Ctrl-Alt-Delete or Ctrl-Alt-Break. If you press those three keys together, the computer will stop what it's doing and give you a set of options to do something with. Most people who use desktop devices will have pressed Ctrl or Delete at some point in their lives. If not, give it a go now and you'll see the menu flash up on your screen. And finally, the last one, we have software errors. If there's a problem with a line of code in a program, there's missing data that the program is looking for. But any errors within software, again, will tell the CPU that there's a problem, it will interrupt it and stop whatever's happening. So hopefully that explains what an interrupt is and how an interrupt can occur. But then what we need to be able to do is to explain what the interrupt service routine is, or the ISR for short. Because once an interrupt signal has been sent to the CPU, a certain routine takes place. And again, this is the job of the OS to make sure that this routine happens so that the computer can solve the interrupt and get back to whatever it was doing. So these set of instructions here tell us exactly what goes on when the interrupt service routine takes place. The CPU receives the signal and the ISR is run. It then will want to act as quickly as possible in order to solve the problem that has caused the interrupt by stopping the CPU from doing whatever it was doing, putting it to one side, dealing with the interrupt so it can come back to what it was doing beforehand. So as you can see, the interrupt is generated, the ISR is called, it's run, it does these steps, and then the processor will return to the previous task that it was doing. So if you've got an internet browser open and you're on a website, you plug in a USB drive, it flashes up on your screen, what would you like to do with this USB drive? You press on the button to open the folder to view the files, it returns to the previous task, and you can go back to browsing the web. Now this is the same for any interrupt, whether it comes from any of these examples here, the ISR will be called and this is what it will do. But again, it's just showing that technical knowledge and using the buzzwords such as the ISR, the interrupt handler, and just generally explaining what these terms do. And the last job of the operating system is to provide some kind of security, and this kind of ties in with the management of user accounts because it has things like passwords, PIN numbers, fingerprint scanners, or even facial recognition. All of these are offered by the OS and offers some kind of security in order to protect your files, protect your data, and stop just anyone from using your device. It also has things like system restore and backup, again, which we can class as security, as it keeps data secure, but most importantly, a job of the operating system, like we keep saying. So that's the last job of the OS, and although that's a lot to get through, you can understand what's going on in each one. You just have to break it down and think about the real-world examples that you use on a day-to-day basis. And then our last learning objective of today is to understand this term firmware, and again, this ties back with Unit 3 when we looked at ROM. So you should be familiar with some of the terms on this page, in particular the BIOS, which is stored in ROM. But the term firmware, firm's kind of in the middle of hard and soft, as with the BIOS being a type of firmware, it kind of lives in the middle because it is a piece of hardware, but it has lines of instructions pre-installed to it. If we think back to what the ROM actually stores, which is the startup instructions, we mentioned that these instructions are installed in the factory when the ROM is made. And like we've learned in this lesson, lines of instructions are what we call software, but as this has both, we use the word firmware as it lies between the two of them. So hopefully that makes sense. It's not too difficult to understand, but we just need to tie the word firmware to the ROM and the BIOS. And then finally this term bootloader, which I've mentioned before as Bootstrap. Bootstrap loader, bootloader, the boot sector, these are all terms again relating back to ROM. And the firmware that is installed on the ROM is what we call the bootloader. Getting yourself ready in the morning is the example that I used. And the term pulling yourself up by your boots or your bootstraps is a term used many years ago, and that's where the term bootloader comes from. A computer booting up or calling the boot sequence, again, just tie that to the ROM, to the BIOS, to the firmware, and all of these terms will hopefully make sense. So just before we finish, these 4 learning objectives, quite a lot to get through in one lesson, but we've managed to do it. As I've mentioned, Unit 4 is only small, and I think there'll only be 2 or 3 more lessons within this unit. But again, hopefully we can go through these and tick each one with a good understanding so that we can move forward. As always, guys, thank you very much for watching, and I will see you in the next lesson of Unit 4.